On the underside, we have an upgraded barometer chip. It sits just there. Because it's on the underside, it's not going to be affected by light the way the other one was. It's also better protected in general on the underside, and it's a much more accurate, much more sensitive chip. So really looking forward to see how well this performs. I've been told we won't need to do the foam anymore, which will be really cool. And if you do decide to do foam, remember you never glue it to the actual Paris, because if you block, there's 2 tiny holes there, if you block them, it don't work anymore, and it's a really bad karma. While we're on the underside of the board, you've got the micro USB connector, which is hand soldered, and it's soldered through as well, so it should be fairly rugged. And Multi-Wii are supplying with the Paris version 5 their micro USB lead. Very nice of them to include that with the board. Also on the underside, we have the good old-fashioned noise bridge remains from previous versions. I've covered this. When you want to run an external BEC, you can desolder that link and run split rails. So that link is still there. So not used so much these days, but a very, very important feature from the past. Okay. We've also got some options available for the board, which I've been included. There is an updated OLED that actually runs a 5-pin connector. The actual board itself is the same, but the 2 I2C bus connectors here run 5-wire plugs, so you need the 5-wire OLED. Now this is an important feature because this gives you all of the data. In fact, when you power this up sitting on the bench or just powering it up at the field with the GPS and everything running, it tells you straight away on this how many sats you've got, your latitude, longitude, and that data's there, ready, visible. You can also use the sticks on your radio with the OLED to tune all the things like your PIDs and stuff. So this is a complete field program, and I think they're about $20. So very, very worthwhile, very worth the money, and DJI can't do anything like this. You've got to have something else with you, whereas you can just have this tiny light board mounted on your airframe and do field programming and tuning, plus get telemetry data out of this screen. Now when I power this up and get it all working with the OSD and stuff and mount it up, we'll actually go through and see what sort of data we actually get off this as part of the telemetry. It's quite extensive. In version 2.3 of the code, they went through a lot of effort to increase the amount of data you actually get on the OLED. One thing I did skip was we have the good old-fashioned, the standard LED trigger wire, of course, that you had on all the previous versions of Paris as well. The other option you can have is the Bluetooth module, which wires in here. Now, one thing with the Bluetooth module, you will have to unplug that, just as you did with the version 4 board, before you plug the USB in. You can't run USB and Bluetooth at the same time, but once you've got your Bluetooth set up, you probably don't need the USB lead because you can do everything via Bluetooth. You can dump code, you can set PIDs, you can do everything via Bluetooth that you normally do via the serial USB lead anyway. So up to you, but just remember, if ever you do have a Bluetooth connected, you do have to unplug the Bluetooth when you plug the serial lead in, or things are going to go a little screwy with your code and stuff. Alright, so that brings us down to probably the most talked about feature of the version 5 board, which I haven't mentioned yet, and that is the built-in on-screen display. And basically most of that is the underside of the board. It's actually run from this chip. That's the controller chip for it there. The video chip for it is over here. So pretty much most of that underside of the board is dedicated to the on-screen display. And because cool thing about this particular on-screen display is it all uses the sensors that are already here. So all we do is we take our Carbon Bird camera and we plug it into, there's two 3-pin connectors just here, a bit hard to see, and our camera plugs into the top set of pins. We've got video, power and ground. Now the power pin is just a feed through from that pin to the pin on the underside of this. Actually, I'll just pop that back out, pop that back off. So those two pins, the two power pins, are just connected. They're connected to nothing else on the board. Just those two pins connect through to each other. So if you're running your Carbon Bird video transmitter, which gets the regulated 12 volts off the Andromeda, we just have to plug into our 3-pin lead into it. That 3-pin lead plugs into the bottom 3-way connector. And as I did before, my Carbon Bird camera plugs into the top connector. And the on-screen display works. It's preloaded with code. That's all you have to do to make the on-screen display work. It will get the code from, it will get all of the sensor information that it can from what's on board here. So it gets your position data from the OSD. It gets your artificial horizon sensing from the gyro accelerometer. It gets heading data from your compass, right? And on the board here, hiding underneath this the IMU lead are 3 little pins, and you can solder leads into them or put header pins into them, and they are RSSI sensor, so that if your receiver you're using has a signal strength output, you can wire that to here. There's a voltage sensor input, so you can run a wire from there to the positive side of your LiPo, and it will give you live feedback of the voltage from your flight pack. And there's also a current sensor input, and you could use an external current sensor. I'm not going to go into that. I'll go into the details of all this in a dedicated OSD video. But you could run a current sensor into that pin, and that will tell you the amount of milliamp hours you've taken out of your pack in flight. Really handy information to have on your on-screen display. Okay, but they're optional inputs. You don't have to have them wired up to make it work. Can if you do want to. It's up to you. While we're talking about soldering and pads, there's also these little tiny little solder pads here. They are analog 0 through to 7, A0 to A7 pins in and out that if you want to get funky and do expanded inputs outputs, you do actually have that available. You've got the ground and 5 volt inputs here if you want to run an external BEC, and the board no longer has the LED hanging out the back because you've got LEDs everywhere else. There's 4 LEDs for status up here as well, but if you still want that ultra bright LED off the board, you can solder one on yourself. There's the pins there for the LED. Okay, now back up here, there's this little wiring loom, right, that is plugged from a serial port back onto the board. Now, some people are going to look at that and go, what the hell is that for? Well, that is actually the serial input lead to the on-screen display. And it's done like this for 2 reasons. Firstly, on multi-Wii, that has to be connected to serial 3. But if you're running the Arducopter code, and I said I'd go through that later on the board, that actually has to connect to a different serial port. So what you'll simply do is unplug that, plug it into, I think it's serial 2, but don't quote me just yet. So it'll plug into this terminal here instead, which means your GPS then plugs into that. Anyway, more on that later. I'm not going to the Arducopter. So that's the first thing. That allows you to plug it in differently if you need to. And the other thing it does is, the other reason for the lead, is you get supplied with this lead as with the version 5 board. And this loom can plug into there. And these leads, pins, then connect to it's not round. Okay, these pins then plug into your FTDI, which you may have lying around, or you can buy one from Multiwear, and that then lets you reprogram or update the iOSD if firmware upgrades come along, or you can actually, there is actually a separate graphic user interface available specifically for the iOSD, and therefore you can actually change the options of what you see on screen using that GUI. So this lets you, this lead and an FTDI lets you, by unplugging this loom, program up the on-screen display for the options you want. So that's why that little lead. It looks a bit funky and people are going to look at it and go, what the hell? And think that's not neat. But actually it's a lot smarter than it looks. So there you have it. That's my introduction to the version 5 board. I'll be coming back with detailed videos on the different sections of it and how to install it and update it and stuff like that. The code for this is a bit tricky, so initially you'll be downloading the code off the website rather than, I wouldn't go grabbing a blank Multiwear code for it. And before you go playing with Arducopter, I'd just wait a little while till I have a bit of a play before you start dumping Arducopter code onto it. I've literally had this in my possession for about 20 minutes before I started the video, so I haven't even powered it up yet. I haven't had to play with it yet, but I just wanted to get this video out of the way so you guys got to look at what you get and what it can do. I know a lot of you are really hanging for this board. Yeah, here it is. So I get to now have some fun. I get to do some code on it and stuff like that and mess around with the on-screen display, and then I'm going to mount this up on my Vampire and give it a good fly and see what it's like. So I'll get back to you with a flight report, and I'll also get back to you with more detailed videos later on. See you guys online. Bye.